Hey guys, I'm Miuccamatics and welcome back to my YouTube channel Miuccamatics. Measures of dispersion or variation. So what exactly is dispersion? Here is an example of samples from two populations with the same mean but with different dispersion. As you can see, the blue population is much more dispersed than the red population. In statistics, dispersion, also called variability, scatter or spread, is the extent to which a distribution is stretched or squeezed. The measures of distribution show the scattering of data and shows whether the distribution of observations is homogeneous or heterogeneous. Common examples of measures of statistical dispersion are variance and standard deviation. Coefficient of variation is also another type of measures of dispersion. So now that I have defined what dispersion means, I'll now show you the different formulas involved for each type of dispersion. Standard deviation, it's denoted by the symbol sigma. So standard deviation sigma equal to root of summation x square upon n minus summation x upon n the whole square. And when frequencies are given, this formula changes to sigma equal to root of summation f into x square upon capital N minus summation fx upon capital N the whole square. If you notice, this term in bracket is basically x bar or mean. So we can also rewrite this formula using mean. Now why these two formulas are similar? As I told you in my previous video, summation x upon n, that is mean, the same as summation fx upon capital N, where n is summation f. Basically because x is repeated f times. In this case, here it's x squared, so basically repetition of x squares, so it will be f times x squared. Now we know that variance is standard deviation squared, or in other words, standard deviation is root of the variance. So if you notice, this term under the root is basically variance. Find standard deviation. So this is the given data. We are given with x, so we find the total or summation x basically, which is 186, and we take x square, so we square all the values, so 17 square 289, 24 square 576, and so on. And then we take summation of x square, which is 5156. The standard deviation sigma equal to root of summation x square, so that is 5156 upon n, which is 8 values, so 8 minus summation x, which is 186 upon n, which is 8 the whole square. So we get the standard deviation is 10.13. Another example, find the standard deviation. Here x is given, we find x square by squaring each data. We find the total 399 and 18848. We plug these values into the formula, so standard deviation sigma equal to root of summation x square upon n minus summation x upon n the whole square, and we get the value 19.9. Now when frequencies are given, so we are given with x and f, which is the frequencies. So now if you notice in the formula, we need summation f into x square and summation fx. So first we find fx by multiplying f into x, so 5 into 3 15, 8 into 10 80, and so on. And we need summation fx square. So instead of taking f and multiplying with x squared, we can do it by multiplying fx into x. So fx into x will give you fx squared. So 15 into 5 75, 8 into 10 800, and so on. We need the summation of fx and summation of fx squared, which is 525 and 9825. Substitute the values in the formula to get the answer 6.68. Now standard deviation, now when class intervals are given. So we have the class intervals 0 to 5, 5 to 10, 10 to 15, and so on. Frequencies corresponding to the class interval are given. Now just like before, we find x by taking the mean of the class intervals, the upper limit and the lower limit, or basically the midpoint. So midpoint of 0 and 5, 2.5, midpoint of 5 and 10, 7.5, and so on. We find fx by multiplying these two values, and fx square by multiplying fx into x. Now we find the summation of fx square and summation of fx, and we substitute in the formula. So hence we get the formula, hence we get the value 9.86 as the standard deviation. Another example, find the variance and standard deviation. Class intervals are given, the frequencies corresponding to the class interval are given, x is the midpoint, fx by multiplying these two values, we get fx, fx squared by multiplying fx into x. So we substitute this in the formula, sigma equal to root of summation fx square upon capital N minus summation fx upon n the whole square. So basically capital N is summation f in this case. So sigma equal to root of 311,625 upon 180 minus 7275 upon 180 the whole square. So we get the value of sigma is 9.88. So variance with the formula is variance equal to standard deviation square. So basically 9.88 square, which gives you 97.61. Now we have something called coefficient of variation, which is basically standard deviation upon mean into 100. So it's a percentage basically. Find the coefficient of variation for this given data. So we need to find standard deviation and mean. So we first find the mean. X square, as you know, we just square each data. Mean is summation x upon n. So the total of x upon the number of data points. So 236 upon 8, which gives you 29.5. Now standard deviation equal to root of summation x square upon n minus summation x upon n the whole square. Summation x square, that is 8918 upon n, there are 8 data points, minus, basically this is the mean square, so you can directly take the above value 29.5 and square it. So we get the standard deviation as 15.63. Now coefficient of variation, a standard deviation which is 15.63 upon mean 29.5 into 100, hence we get 52.98%. Now basically when we have class intervals here, class intervals given are 10 to 15, 15 to 20 and so on. Frequencies are given. X is the midpoint of 10 and 15, 12.5. fx by multiplying these two values, and fx squared by multiplying fx into x. Mean, as we know, is summation fx upon capital N, where capital N is summation f. So summation fx is the total of this column, this row, which is 3190 upon capital N, which is summation f. In this case is 100, so we get 31.9. Now standard deviation is root of summation fx square upon capital N minus summation fx upon n the whole square. So root of summation fx square, which is the sum upon n, which is summation f, which is 100, minus, basically this is the mean square, so we can directly take it as 31.9 square. It gives you 7.75. Now coefficient of variation, it's basically coefficient of variation is basically standard deviation, which is 7.75, divided by mean, which is 31.9 into 100, which gives you the value 24.29%.